Now, as you have already seen, we actually don't get both of our images, and if we want to visualize both images at the end when we run our project, we have to use a function called figure. So figure IamShow, and we can also move this down here, so we can say figure. Basically, when we use the figure function, we are saying whatever is below the figure function will be in that figure. When we use it again, we're creating a new figure. So as you can see now, we get two windows, and this is figure 1 and this is figure 2. So whenever you use the figure function, you're creating a new window, and whatever is after the function, you're populating that window with whatever is after the function. So with that out of the way, we will continue with our next task, which is to increase the black in the image, in the original image, by increase it by 50% towards the white. So we're going to take the same image and we are going to make it more whitish. The first thing that we have to do is we have to get the whole image and store it in a separate variable. So black to white image equals to black and white image. So we are simply copying this matrix into another variable that we are going to use in our calculations down here. After that, we have to select and modify all of its elements that are below 150. To do this, we have to perform a logical arithmetic operation, which actually can be quite confusing with matrices at first. I haven't shown you how to do this in the course yet. So go ahead and first try it by yourself. You have to select the values below 150 and multiply them by 1.5. If you succeeded and got a matrix without any additional conversions as a result, good job, very good job. But if you didn't and you keep getting a vector as an answer instead of a matrix, and if you're converting it with a vec to math to a matrix, it works, but it's not the solution. You have to use the colon operator for both your rows and your columns. If you use it only once, it will convert the whole matrix into a vector. So this is how everything is going to work. So this is how it should look. You take the image, so black to white image. You give it the condition, which is black and black to white image. Select the whole matrix, not just a column. If you use only one column, like I said, this will convert it into a vector. So we have to use two columns, so all rows and all columns. Less than 150 equals to black to white, the same thing, black to white image of black to white image of everything in the image, less than 150 multiplied by 1.5, and then visualize it. So we're going to create a new figure. Let's create it after our first figure. So figure IamShow black to white grayscale, and we need to create the grayscale now. So black to white grayscale equals math to gray of black to white image 0 to 155. Let's run it, and there we have it. There are the two images. As you can see, this one on this side is a little darker than the one on this side. If we increase it even more, let's increase it by 80%. So just change this to 1.8. Let's run it again. It's even more evident that this image is more whitish. So here I want to show you one additional trick. You don't actually have to use the math to gray. There is another way. Instead of using math to gray, you can convert the image to unsigned 8-bit integer. And you can do this by saying the following. So black to white grayscale equals to uint 8. This means unsigned integer 8-bit. Unsigned means that it will start from 0, and since it's 8 bits, its maximum value will be 255. So black to white image, let's run it, and it still works, as you can see. Now again, the difference, this is just the same way to perform the same operation that we had up here. So I just wanted to show you that there is another way. Actually, pretty much almost everything in MATLAB has more than one way to be accomplished. So just use the one that is more appropriate for your specific case. So the difference here is not in the values themselves, but in the type. As you can see here we have double, and here we have uint of 8. If we do it like this, you can see that even after we convert it to grayscale, it's still double, but it works. And here we are using unsigned integer 8 bits. So, like I said, use the one that is more appropriate for your case. Now, our final task is to read a black and white image and visualize it and extract a subimage from that image. Now, here I have prepared an image that is, let's try to open it. Open outside MATLAB. So I have prepared this image. Now you can use any image you want, but the image must be black and white. You can't use a colorful image, at least not yet. In the next project we're going to work with colorful images, but here you have to use a black and white image. I have downloaded this image from here, from the website called Pixabay. You can download free images. Just look for black and white image or monochromatic image and download it. It's free to download, so you can pick any image you want. With that out of the way, how do we read the image? How do we read it? Let's go in the beginning of our file and say chess, which will be the name of our image, the name of the variable that will hold the information of the image, equals imRead, and you simply give it the name of the image or the path to the image. Now, if the image is in the same folder where your .m file is, as I currently have it, so as you can see, this is my file that I'm currently working on, and this is the image. If they are in the same folder, you only need to give it the name of the image. So chess B and W, so black and white, .jpg with the extension. If the image is in another folder, you have to supply the full path to that image. Now let's run it like that. And as you can see down here, we get a chess image, which is 747 by 1280 of unsigned integer 8 bits. So when MATLAB reads an image, it reads it in the type that we used here. And we can now visualize it. To visualize it, well, we are going to use the same function again. So figure show of chess. Let's run it. And there we have it. MATLAB can read and visualize that image. But what we want to do with this image is we want to extract a sub-image from that image. Let's open the image in Paint. So here we have the image opened in Paint. I used Paint because it's very easy to take measurements with Paint. What we want to do is we want to extract the king figure, the top side of the king figure. This is what we want to extract in a standalone image. To do this, we have to find the location and size of this rectangle that I have here. The way that we're going to do this is we're going to measure the height. We're going to measure the width to that figure. So the height is about 89. And we start somewhere around here. This will be, the width is 860. You can see down here, this is the size of your current selection. So let's say 870, 87 and 870. Let's go back in our MATLAB, and so we have row 87 and column 870. Because remember that this is actually a matrix. This whole everything is a matrix. So we have 870 columns and 87 rows to get to our top left corner of our selection. And now what we have to do is move within that submatrix that we are selecting here. The selection is roughly 185 by 300. So let's use it. So height is 300 and width is about 170. So let's save all of these values in separate variables. So chess figure column, starting column. This is the initial column, 870, chess figure row, 87, chess figure width, 170, chess figure height, 300. To extract this image now, we simply have to select this portion of the matrix, and we are going to do it the following way. Chess figure is equal to, first we need to specify from where to where are our rows. We start from chess figure row, this is our starting point for the rows, and the end point, you're probably thinking that the end point will be the chess figure height, chess figure height, and we're going to see what will happen. Same thing for the columns, chess figure columns to chess figure width. Now, I'm going to go ahead and tell you that this is not going to work, and it's not going to work because, what is the problem here? We have to use chess here in the beginning. Alright, so why this is not going to work? This is not going to work because when we start from chess figure row, which is 87, and chess figure height is 300, this will make us go from 87, which is the correct thing here, up to 300. So we're going to start from 87, somewhere around here, and we're going to go up until 300. And as you can see, this is nowhere near enough for our image. We want to go down here. Now let's visualize it, see it, and then figure out how to fix it. Figure I'm show of chess figure. Let's run it. Actually, it doesn't even visualize. Why? Let's see what are its contents. We don't actually have anything in it. So the correct selections are to start from the chess figure row and continue from the chess figure row until the end of the height, which means chess figure row plus the height. The same thing for the columns. So let's move it to the next row, chess figure columns until chess figure columns plus chess figure height. Let's see if it's now going to work. Brackets, brackets, brackets. And there we have it. There we have it. Precisely what we wanted. So again, how does it work? When we start from 87 or something like that, we want to proceed 300 rows down. If we say from 87 to 300, we get only to here. But if we say 87 plus 300, we will get the correct final height. So this is basically what we are doing. We are finding the final height and the final width. The final height is from 87 to 387, and the final width is from 870 until 1000 and something. So there we have it. The only thing that's left to do is to document our code, and we are done with this project. So here we have our initial data. Then we are converting the data to grayscale and extracting colors. Here we are converting the generated image to grayscale. Here we have extract gray gradient over 180. Here we have increase black towards white by 80%. And down here we're extracting a specific piece from the image. And finally we are visualizing them. So visualize the images. Figure creates a new window for each image. There we have it, our final project.